Okay, okay. Get everything situated. Sweet. Alright, so here's our video notes for PreCal Monday, May 30th. Alright, so before we get into the stuff for this week, a few little like class announcements-y things. One, here on Google Classroom, juniors going into the 12th grade, here's a link for you to make your course selections for next year. If you want to have a discussion with me about as far as what you should register for, obviously feel free to reach out and I can try to help you out with that decision. Okay. Down here it just asks you to put your full legal name, your high school ID, what you want your English class to be, what you want your math class to be. So you guys, algebraic reasoning, calculus, statistics, college algebra, yeah. A college prep math class looks like they're trying to put on there. Some of these math classes make depending on how many students sign up for them. So kind of keep that in mind too. If there's something that you're interested in, sign up for it. Okay. Alright, so that's there. Try to get that done as soon as you can. Seniors don't have to worry about that. Alright, so for this week, just showing you guys the tutorial schedule again. I'm sure everybody knows when things are available. X'd out last week because it's over. Here's this week. I haven't made this slide for next week quite yet. Here's all the different links and things that you can need. So this week we're gonna review the factor theorem, how to use synthetic division just to tell if something is a factor or not. It's how you typically get like rational solutions, either whole numbers or fractions, to tell if those are x-intercepts. And then we're going to go over solving polynomial equations tomorrow, so things that don't have nice x-intercepts, how do you go about finding them, especially things with like complex solutions and whatnot. And so for lesson 1, you've got a blank copy of the notes here, if you want to copy them down or print them out, depending on what you've got available at home. Here is a teacher copy of them, essentially what I'll be going over. Then there is the activity. You always have a digital and a paper version. So the digital activity just is two maze activities. Is this thing a factor or not? Navigating your way through. All you have to do is like duplicate these arrows, but it's making a copy of them and moving them around to show the pathway. I have no idea if that's the answer or not. Okay. Or you can do the paper version. Same idea, print it out, show me the path. Either option, make sure that you upload a photo of your work, so I know that so I can see if you have any like common errors or anything like that, if something was going on. Okay, so we're going to go ahead and get started. Let's see here. So factor theorem. Given a polynomial function f of x, x minus c is a factor of f, if and only if f of c is equal to 0. Okay. It's only an x-intercept if you plug it in and you get 0 back, which makes total sense because x-intercept is when you have a y value of 0. Right. So you can do long division. I don't recommend it, but you can. So we're going to use synthetic division to determine if these things are actually factors or not. So the things you want to remember with synthetic division, it's all about your coefficients of your original polynomial, and you still want to remember to have 0 placeholders. So let's see, so we have 1x cubed, 0x squared, negative 31x, and 30 as my constant. First one always gets brought down. Now if we're testing the first factor, say we're testing x plus 1. So what it's saying is, what we're testing is whether or not negative 1 is indeed an x-intercept of that factor. So we're actually going to have a negative 1 outside of our little setup here. Then at this point, it's mad. Multiply, add, down. So negative 1 times 1 is negative 1. Then I'm going to add down and get negative 1. My Apple Pencil wouldn't tie. The most inconvenient of times. multiply a -1, -1, get a +1, add that to a -31, get a -30. Unicorn iPad. I mean, I can't see it, but it's there. -1, -1 is a +1, get a -30, get a +30, add down, and we do get 60 as our remainder. So, not a factor. Then we'll do the same process over again with a -5, x minus 5, and x plus 6. Luckily, the stuff written in black won't change for this problem, just testing different values. -31 plus 25, -6, yeah, plus a -30, which gives us 0, which we want. And then x plus 6 is our last one. -1 times the positive, -6 times +1 to the -6, add that to 0 is -6, multiply them together, get 36, add down, get a 5, multiply, third, -30, and a big ol' goose egg. Yeah. Okay. First example. Probably not going to do all the ones in the notes. It's pretty redundant after a while. Okay, so that's just a slightly larger version of the problem. Let's use the factor theorem in the given binomial to factor polynomial, then give all the zeros. Look at that. Okay, she doesn't do any with the leading coefficient. That's mildly annoying. Alright, I'm going to go off script a little bit here and actually pull one of the problems from the assignment to do. Simply because all these examples only have like one x rather than having a coefficient on that x value. So I'm going to find a problem. Okay, cool. Paper activity. Well, isn't that lovely? Doesn't start off that way at all. For sake of example, you can still determine whether or not something is a factor, even if it has that leading coefficient, for example, like on this guy, whether or not he is indeed a factor of this problem. You don't have to use long division in that case, but it hinders being able to find the other zeros later on, but it's still perfectly fine for the test. So I'm going to test whether or not 4x plus 5 is indeed a factor of x cubed minus 13x squared plus 52x minus 60, and see if it is a factor, yes or no. Okay. So a little bit off script here, but whatever. Okay, so I'll set up my synthetic division. I've got 1x cubed minus 13x squared, 52x, constant of 60. Okay. So what we want to do in this case, if we're trying to test whether or not 4x plus 5 is indeed a factor of that given polynomial, okay, so 4x plus 5, we're seeing is what is that when it's equal to 0? Again, because x-intercepts have a y value of 0. So if I was to solve this for x, I'm going to subtract over the 5 and divide by 4. And get x is equal to a -5/4. That's the value that we're going to use through our synthetic division. So it's quite lovely. Okay, so 5/4, negative 5/4 times 1 is a negative 5/4. I don't want to. Hold on. The handy-dandy Desmos for when I don't feel like dealing with fractions. I mean, if you want to change it to decimals, you can. It still works. So you have a negative 57/4. I'm going to multiply that result by a negative 5/4. And get 285/16. Add that to 52. 1117/16. Multiply that, get a negative 5585/64, which I don't know what that is, but it is not 0, so not a factor. I think that's alright. I do want to double check, make sure I haven't done something ridiculously silly on that problem. Just to be on the safe side. Okay, yeah, no, that one wasn't a factor of that guy, but I will do one to show you one that it is a factor. Okay. So in addition to that problem, I'll do, so that's not a pathway that you end up taking in this assignment. It's actually not even one you end up having to test, but it's there. What I will tell you is that this is a correct pathway. And so we're going to show why 2x plus 1 is indeed a factor of 2x cubed minus 13x squared plus 17x plus 12. Blech. Mouthful. Two, negative 13, 17, 12. Bring down the 2. Okay, so 2x plus 1, if I set that equal to 0 and solve that for x, I would get a negative 1/2. That's what I'm going to test. So negative 1/2 times 2 is negative 1. Negative 1, negative 13 is negative 14. Times a negative 1/2 is a positive 7. That gives us a, right? Yeah, 7, okay. And then that's 3, so that's 24. Negative half of 24 is negative 12. 0. Okay. Behaved much nicer. So yeah, that is indeed a pathway there for this problem. Okay, and that's just about the level of work though that I really need to see. That is all. I know I didn't really do a whole lot from the note page itself. It's not particularly difficult stuff. Like I said, most of what we're reviewing is this thing a factor, yes or no? Not necessarily taking it the full way and saying, okay, yes, that one is a factor, now tell me all of the other ones. We're not going that far in these problems, but those notes are on here if you wish to see them. Okay, I'll be on Google Meets here in a little bit if you have any questions. Thanks.